Hi, in this video we are going to talk about the in-order traversal in a B tree, so let's get started. It's basically very similar to what we have discussed for binary search trees, AVL trees and red-black trees. Okay, it is a bit trickier. So let's start with the first item in the root node. It is the 17. We pose the question that, okay, does this key have any children at all? And yeah, it has a left child, so we keep visiting it. The 2 doesn't have any children at all, so this is the first item in the in-order traversal. Then we keep visiting its neighbor keys, because it's very important that for a B tree, there are several items and several keys in a single node. So we keep visiting the next one. Does this key have any children? No, so it's going to be the next item in the in-order traversal. Then we keep visiting the neighbor, which is the 11. It doesn't have any children. Why is it important? Because if it has a children, then we have to visit it in a recursive manner. But here, it doesn't have any children at all, so it's going to be the third item in the in-order traversal. We have managed to visit all the keys in this node, so basically we backtrack to the original key, which is the 17, and we visit it. Basically, before visiting the neighboring 23, we have to take the right branch, which is this. And we have to consider 19. It doesn't have any children, so it's going to be the next item in the in-order traversal. We visit its neighbor because it doesn't have any children. And the 21 again doesn't have any children, so it's going to be the 6th item in the in-order traversal. And we backtrack because we have finished with this node. 23 is going to be the next item in the in-order traversal, and we have to visit its right branch, which is another node with another keys. 34 doesn't have any children, so we visit it. Then we keep visiting its neighbors, 56, then the 67, then the 70. We come to the conclusion that, okay, that's all about this node, so we backtrack to the 71, we visit it, and before visiting 89, we have to visit the right child of 71. And we have to consider this node. 78 is going to be the next item in the in-order traversal because it doesn't have any children. What about its neighbor? It doesn't have any children, so we keep putting it into the in-order traversal. Okay, we keep backtracking and we keep visiting the 89. Then we keep visiting the last branch of this root node with the 92 and the 99. We came to the conclusion that these keys doesn't have any children, so that's all about the in-order traversal. So 2, 3, 11, 17, 19, 21, 23, 34, 56, 78, 70, 71, 78, 80, 89, 92 and 99. Okay, it is apparent that again for B trees as well, the in-order traversal is going to yield a numerical ordering for integers, but if we store, for example, characters or strings in a B tree, then it's going to yield the alphabetical ordering. So this is basically why we like in-order traversal, because this is how a tree-like structure is able to do the sorting operation. We just have to make the in-order traversal. And it is the same for B trees. We just have to take it into consideration that there may be several branches from a single node, as we have seen for the root node in this case. We have 4 keys and we have 5 children, so 5 branches, and we have to consider all of them. So that's all about the in-order traversal for a B tree. Thanks for watching.